Chapter 5 Galvanic Cells. So, today in this session, we'll talk about the common design features of a galvanic cell and the chemical process that's involved. So, first of all, what is electricity? We use electricity all the time, but what are they? So, they're basically a flow of charges, or we can say charged particles. Yeah? So, when charges, for example, electrons, when they are not moving, there's no electricity. But when they move, there is. So electrons move will produce electricity. So we simply just need to make them move. So in chemistry, how do we make electrons move? We use redox reactions, right? Redox reaction is about transfer of electrons. If electrons can be transferred, then we can make them move the way that we want. So, of course, redox reactions can be used to produce electricity. In fact, a lot of batteries that you buy from supermarket, they are basically a redox reaction that turned into electrical energy. Yeah? So anything that turns chemical energy into electrical energy is called an electrochemical cell, which is the galvanic cell that we need to study today, which is this part, the battery. So galvanic cell is a cell that uses redox to produce electricity. So the cell uses reactions between, for example, zinc and copper. Do you remember this reaction? When zinc strip is put into copper solution, then copper solution fades, and then there is copper deposits. So that is a redox reaction. So if we separate these two half reactions, which is the reduction half and oxidation half, and we connect a wire between them, so then the transfer of electrons will not happen directly on the surface of zinc strip or copper solution. It will happen, electrons will transfer from the zinc end through the wire, because wire has no resistance and electrons will always go through the things that has no resistance. So the electrons that's lost by zinc will go through this wire and then arrive at the other end, which is the copper end, and then copper will be reduced on that end. So the transfer of electrons can be facilitated by a wire, and if you connect any electrical appliances on this wire, then these appliances, this thing can be powered. Yeah, it will light up. So the design features, the key components of a galvanic cells are as follows. First of all, you have two half cells, yeah? The negative half and the positive half. So here we must remember that anode is defined as where oxidation happens. So since zinc is losing electrons to become zinc cation, so this part is the oxidation half cell, and therefore this is the anode. And the other end, copper is being reduced, gaining electron to become copper solid, and therefore this part is the reduction half, and therefore that's the cathode. And electron, where electron comes from, is defined as the negative end. So that's why anode is negative end here. And where electron arrives, that's the positive end. Yeah? So how do we remember this? Well, since reduction is cathode, so we have red cat. Yeah, just remember this red cat. And then oxidation is anode. So anode is oxidation. Anox. Remember an ox. Okay? So these two half cells is connected by a wire, and on the wire you can connect in any kind of electrical appliances. But inside this cell, they also needs to be connected by something we call a salt bridge. So a salt bridge is normally, you can see it's a gel-like substance that connects these two half cells, and in these gels, they're soaked in a salt. By name, salt bridge is full of salt. Or sometimes they can simply be a strip of filter paper that's soaked in salt. Yeah, they have two functions. First of all, they complete the inner circuit. So you can see that this entire circuit is completed by this salt bridge. On the other hand, they need to neutralize the accumulating charges. You can see here on the anode, zinc is going through oxidation to lose electrons. So here, zinc cation is continuously being produced with nothing to neutralize it. On the other hand, copper cation is being reduced to become copper solid. So this solution is constantly losing copper cation with nothing to supply. So that cannot happen for long. If this keeps happening, then this entire reaction will stop. So we need to constantly balance these accumulating charges. So here, salt bridge, the anions in the salt bridge will come here to balance the cations that are constantly being produced. And the cation in the salt bridge will continuously come here to supply the cation that was lost because this reduction reaction. So they neutralize the accumulating charges in both half cells. Here there's an animation will give you a better understanding of it. So you can see that zinc is going through oxidation, and therefore electrons being lost flows through the wire, through the external circuit, and come here to reduce the copper. And then on the same time, zinc is constantly being produced. Yeah, zinc cation is constantly being produced. So the salt bridge comes here. Okay, so the salt bridge, potassium from the anion from the salt bridge comes here to neutralize the accumulating cation, yeah, and then the cation from the salt bridge comes here to supply the cation that was lost here. Okay, so these two. Well, let's do a summary. So first of all, what we are learning today is everything that's happening inside here. Yeah, we have two half cells, anode and cathode, and then the electrons always flow from the anode, because that's where electrons is being produced, and flow all the way to the cathode. Yeah, and then of course we have salt bridge, and we must know the two functions of a salt bridge.